This short video is designed to display and describe how 3D laser scanning can take images of existing structure and how it can associate those images um, in a format where accurate measurements can be taken. This particular project and this 3D laser scan was taken because it was a very difficult situation. We had a new structure that was completed next to an existing structure, and then new steel, a new roof had to be placed over top of the existing structure to carry the snow load that was going to occur from snow drifting off the taller new building onto the lower existing building. And the new steel had to connect to existing steel below, which was in an operating store. And so all of this had to be done without disrupting the store below. And so we had slopes to work with, slopes that needed to be done, um, lots of things. So I'll show you just we'll just go into it, and I'll show you just what we did. The first I'll just mention here that there's a whole series of scans taken. The first scan was taken here, and they're taken in a manner that references images that were taken in the first scan will be also viewable in the second scan, and then the software that we're using, which is what you're looking at right now, will associate those scans, and uh, and the end result is that we've got something that we can view the whole project together beyond barriers like walls and roofs, um, and we can make accurate measurements. So starting here, I'll just go into that. Here's the kind of images that the scanner takes. This was a Leica rtc360. Um, this while this looks like a picture, it's actually made of millions of uh, laser created points, and is possible to measure from say here to here, or the width, or measure the width of anything, measure the width of this window. Anything can be measured that you see. The scan takes in everything. In it doesn't, and so it's very useful for measuring things like the concrete, which was something that we had to do earlier in the project, um, and existing steel, that sort of thing. Now, the purpose for taking this scan and the next 2 or 3 scans was that we needed to be able to reference new steel. That is, this is the new steel in the new building, because all of our grid lines are associated with this steel. So we took scans from various points, and that allowed us to reference these beam locations and the columns here. Um, we had enough of those views that we could reference those, and uh, and then project our grid lines into the existing building. And so the next scans were at the doorway, and we're starting to create a path into the building. We can still see our existing structures. We've got edges, we've got images that we can associate to, but we'll keep associating those images as we go into the store. So now we're into the store, and you can see the kind of detail. Everything everything can be measured. We could have measured the spaces in between this mesh if we'd have wanted to. The size of the doors, anything that you see here can be accurately measured, probably within 1/8 of an inch. And so this image here, which is still taken at the ground level, is associating with the images that we took before, and that's allowing us to project our grid lines into this side of the building. And of course the new steel is going to be on top of this roof, and the new steel coincidentally is already cut. And so we had to make certain that the columns that are going, I'll just take you up there now. So here we are. We can still see the we can reference to the lower steel below, but here's our new steel. As you can see what we're having to put new steel on top of this beam for what's the beam farthest from the new building. And we have to make certain that we're not going to be interacting with this conduit and different things like that. Um, and so this corner we couldn't get our scanner in there because of the boxes, but there was some conduit to work with in that corner. And the other, the other beam that we're connecting to is here. And and I'll show you that when we get to the roof. So I'll just show you some scans from the inside of the building. Just all of these pictures are taken. Oh, pardon me, I had to clear my voice. All of these pictures, all of these 3D point scans are taken in full color, and so we have all of the detail that we needed to know what we were dealing with, and that was the distance between the joists, and the distance between the joists wasn't consistent. It varied half of an inch from joist to joist because this was an older building and they were welding the joist down to the beam in those days. And so we've got all that information. I'll just go to the other end of the building. See if we can get. So here's the wall there that we were connecting to, and we had to know the column locations. In this case, we know that there's a column here. All of these things that we had to know, and then we went to the roof. And starting on the roof, we took a scan out in front of the building, which we could reference to our previous scans inside. And that gives us a scan looking upwards to capture these edges, which we're going to be working with. You can see the kind of detail that we get. And then another scan here to take in this edge, which we needed to know, and then we can move up to the roof. And here on the roof, we've got captured these edges in the thickness of this wall, these different measurements that we needed. Of course, any of this can be measured to, but everything is captured. We don't have to think, well, we should have measured that later when we get home. Like, we've got everything. And the one beam line that is going to be right along this this object here. So you can see that we've got everything there, and then as we move around the roof, we can just capture this. Everything that we see in this image can be measured. And so here's our one beam line along here, but the other beam line is along here. And that was very difficult because, oh, I needed to be on the roof. All of this had to be demolished, and we had to know where our steel was going to be. So that's the difficulty. And so then you can see how we can associate objects in the one portion of the building, which is the new steel, project our grid lines over to this roof level. Also, we know what's going on with the area underneath the roof. I'll just go back to this view. What we learned in our 3D scan is that the roof is not level. It slopes from this grid line down to here 5 inches. This beam line here is straight, except it cantilevers here, and the steel is sloping from this skewed wall down to this area 5 inches again. So we had slopes going 2 directions, and we had to be aware of that for our new steel above. which was very useful information. And so then that's essentially what we're looking at here. You can see the clarity of the images, and um, uh, all of these images, all of these individual point clouds can be imported into the structural modeling program, which is what we did. And so we had a model of the existing structure, both from the new structure that we had here. We could take the point cloud from here, um, insert that into our structural model, overlay the point cloud exactly over the existing steel. Um, that took a little bit of time because it had to be precise, and then we could project that into um, the warehouse storage area here. We could measure the location of the existing joist and reference through the walls, um, through the barriers and through the walls. I'm sure we've got a, if I spin around here. Uh, so that was very important. Barriers did not bother us here. The accuracy of the measurement is within about an eighth of an inch, I should say. So we could tell where all the column locations were. We knew where the conduit was. We knew where everything was going on here. And then we could reference that to the rooftop and the objects that we had there. For instance, this area. And we had a complete and comprehensive um, set of points that we could measure from, reference to, and even include in our structural model, so that when we're modeling the steel, we knew exactly what we were doing. It just took all of the questions away from it, and the steel was able to be fabricated in a different city, trucked to this city, and erected without any problems. And so that is exactly what 3D laser scanning can do. So that's what we wanted to show you in this video today, and thank you for taking the time to look at it. Uh, you'll see, our website is listed in the video, so uh, call us if there's something that we can do. The machines are very portable, and we can take scans anywhere in North America. So, okay, thanks.